Simulation here that's looking at mental health beds. Now, we're considering two different configurations here. I'm going to start this simulation running so you can see the movement. So these are exactly the same bed bases. We've got 16 beds, and we've got patients coming in that are going to require these beds. They're going to stay X number of days and then they're going to leave. But our exam question here is, should I admit patients for 7 days, so Monday through Sunday, or should I just do it for 5 days? Now, if I do it for 7 days, we should be able to smooth things out because we are taking in slightly less patients per day. So there's 14 patients coming in per day compared to 16 if we admit for 5 days. So that should mean that there's less queuing potentially. But the problem is it might cost more because we need to staff it for 7 days if we are admitting patients, and there are specialist staff that are required for the admitting process. It might be harder to actually get people who want to work at those hours as well. So it's an interesting question, and one that we're using simulation for because it allows us to look at all of those factors and quantify them. Now, what I'm doing, first of all, is just doing one run. So it could be that this run, which is going for 2 weeks, is one that's a good run. That's in the top 5% of all weeks, or it could be that it's a poor one. So we wouldn't want to really make any decisions off this one run. I'm just going to fast forward this simulation a little so that we can come to the end. We're at the end anyway. So over 2 weeks, we can see some interesting things here. When we look at the wait for a bed, the maximum we've ever had the queue grow to is 5 patients who are waiting for a bed. It's not that serious kind of mental health conditions. This is like a rehab facility more than anything. So a 5-day, a 5-person wait is bad, but it could be considered acceptable. If we have 5, just run for 5 days, then we might have slightly longer waits. And what's interesting here is on this particular run, it seems like the Friday we had a bigger wait than the other days. And this is something where I would question, is this just natural variation, or have we got more arrivals on a Friday? And are we is that because we are trying to get more patients in? There are patterns that I would imagine would stay true though. So we're only admitting patients for 5 days here. So this is how many beds are in use. And you'll see there's this big dip over the weekend. If you're not admitting people, you're still going to discharge people. So we're going to see this dip here. And similarly here, it looks like the 16 beds is kind of enough. We might use the simulation to create a business case for more. So that one run is interesting, but to make any kind of real analysis and understand the risk in decision making, we want to do multiple runs. And if I just show you some of the features that are going to change here. So how many night stay is important. This is taking real data, and we can see that a lot of patients will stay 4 or 5 days here. The big majority will only stay for that amount of time. That might be because there are set programs or anything like that, but you can see a small percentage actually can stay as long as 12 days. Some are in and out very quickly. So this is a thing where actually, if you are unlucky enough to have a few patients who sample that they're going to stay for 12 days, you're going to have a worse result. So when we run this simulation, what I'm going to do is now run 5 runs automatically. Now you could choose more than 5, and there's a mathematical way that's automatically calculated in Simul8. But what I'm going to do here is automatically look at 5 runs and take an average from them, but also a confidence interval. You'll maybe notice things as this simulation runs that these patterns, although they're, we're seeing spikes, they are slightly different. I'm not always seeing that same spike I saw in the first run on the Friday, for example. So I do these 5 runs, and then I take my results dispersion. So over 7 days, I can see that I'm utilizing my beds better. I've got a 90% on average occupancy. Whereas over 5 days, I'm only occupying them for 7, where our beds just aren't going to be utilized. So actually, if you are doing it for 5 days, it might be that you need slightly more beds. That's the kind of trade-off you might make an argument with the simulation for. Now, this is an interesting result. The percent that stay less than the time limit, there's a lot of variation here. So on the 5 days, we can see that we're still achieving our target 89% of the time on average, whereas for the 7 days, it's 99% of the time. So it seems like the amount of beds are coping really well on the 7-day run, not quite as well on the 5-day run. But what's interesting here is if we'd have just done the 1 run, it could have sampled that we hit 98% on the 5 days and 97% on the 7 days. So actually doing all of these runs and reporting the variation that exists gives us a really good sense of what the risk's going to be around a decision. And we can see we're looking at the bed use, we're looking at waiting times, but we're also looking at cost and revenue. Over 5 days, our fixed costs might be less, but our revenues might be higher. And we can compare all of this within a simulation.